What specific problem does your research address regarding the performance of language models like O1 in the medical domain?
Our research addresses the specific problem of evaluating the performance of language models like O1 in the medical domain, particularly focusing on their capabilities in understanding, reasoning, and multilinguality. We identified that existing benchmarks often assess models based on limited factors, which do not provide a comprehensive evaluation of their capabilities in complex medical tasks. Our study assembled 35 existing medical datasets and developed 2 novel QA datasets to ensure a thorough assessment of O1's performance. Key findings indicate that while O1 shows improved clinical understanding and reasoning, it still suffers from issues like hallucination and inconsistencies in evaluation metrics. This highlights the urgent need for consistent and unified evaluation metrics for future language models in the medical field.
How does the proposed method work? Illustrate the algorithm step by step, including any novel techniques or components introduced in your evaluation process.
The proposed method for evaluating the O1 model involves a structured evaluation pipeline that focuses on 3 key aspects: understanding, reasoning, and multilinguality. First, we collected 35 existing medical datasets and created 2 novel QA datasets, ensuring a diverse range of tasks that align with real-world clinical needs. The evaluation process incorporates 3 prompting strategies: direct prompting for specific problem solving, chain-of-thought prompting to encourage step-by-step reasoning, and few-shot prompting to provide examples for learning input-output mappings. Metrics such as accuracy, F1 score, blue, rouge, and align score are employed to measure the model's performance against ground truth answers, allowing for a comprehensive assessment of its capabilities. Notably, the integration of chain-of-thought prompting during training enhances the model's reasoning abilities, demonstrating significant improvements in accuracy across various clinical tasks compared to previous models.
Can you provide a simple illustrative example of how the O1 model performs a clinical diagnosis task using your evaluation metrics? Walk through the main steps involved in that process.
In our evaluation of the O1 model's performance on clinical diagnosis tasks, we utilized a structured approach focusing on understanding, reasoning, and multilinguality. For instance, in the NEJM-QA dataset, O1 was prompted with a clinical question requiring it to select the correct diagnosis from multiple choices based on provided medical information. The model's reasoning capability was assessed by measuring its accuracy, which showed an average improvement of 8.9% over GPT-4, achieving a score of 79.6%. Additionally, we employed metrics such as accuracy for multi-choice questions and align score to evaluate factual consistency, revealing that O1 not only provided correct answers, but also generated concise responses without hallucinations. This process illustrates O1's enhanced understanding and reasoning in real-world diagnostic scenarios, demonstrating its potential as a reliable clinical AI system.
What theoretical or practical benefits have you identified for using O1 compared to other models like GPT 3.5 and GPT-4 in medical applications?
The O1 model demonstrates significant theoretical and practical benefits in medical applications compared to GPT 3.5 and GPT-4. Specifically, O1 shows an average accuracy improvement of 8.9% and 27.1% over GPT-4 and GPT-3.5 respectively, in newly constructed challenging QA tasks, indicating its superior reasoning capabilities in clinical diagnosis scenarios. Additionally, O1 excels in mathematical reasoning, achieving a 34.9% accuracy on the MedCalc bench, surpassing GPT-4 by 9.4%. In complex reasoning tasks involving multi-turn conversations, O1 outperforms both GPT-4 and GPT-3.5, with accuracy gains of at least 15.5% and 10% on the Agent Clinic benchmark. Furthermore, O1 provides more concise and straightforward answers, reducing the incidence of hallucinations compared to GPT-4, which often generates incorrect explanations. These improvements suggest that O1 is a step closer to functioning as a reliable automatic AI doctor in clinical settings.
How was the O1 model validated in your study? Can you describe the experimental design, datasets used, and metrics that demonstrate the effectiveness of the approach?
The O1 model was validated through a comprehensive evaluation framework focusing on three key aspects: understanding, reasoning, and multilinguality, which correspond to real-world clinical needs. We utilized a total of 37 datasets, including 35 existing medical datasets and 2 novel QA datasets, to assess the model's capabilities across various tasks such as concept recognition, clinical suggestions, and mathematical reasoning. The experimental design involved comparing O1's performance against other models like GPT-3, 5, and GPT-4, with specific attention to accuracy improvements in newly constructed QA tasks, where O1 showed significant gains of 8, 9% and 27.1% over GPT-4 and GPT-3, 5 respectively. Metrics employed for evaluation included accuracy, F1 score, blue, rouge, and mauve, which collectively highlighted O1's superior performance in generating concise and accurate responses while also addressing the issue of hallucination. Overall, the results indicated that O1 is making strides towards becoming a reliable clinical AI system, as evidenced by its enhanced reasoning capabilities and improved performance in complex diagnostic scenarios.
What significant results did you achieve with the O1 model in terms of accuracy and capability in real-world medical scenarios? And how do these results compare to the previous models employed in your study?
The O1 model demonstrated significant advancements in accuracy and capability in real-world medical scenarios, achieving an average accuracy improvement of 8, 9% and 27.1% over GPT-4, 79.6%, and GPT-3.5, 61.5%, on the NEJM-QA and LACENT-QA datasets respectively. Additionally, O1 excelled in mathematical reasoning, elevating the baseline of the MedCalc bench to 34.9%, surpassing GPT-4 by 9.4%. In complex reasoning tasks involving multi-turn conversations, O1 outperformed both GPT-4 and GPT-3, 5, with accuracy gains of at least 15, 5% and 10% on the Agent Clinic benchmark. These results indicate that O1 not only provides higher accuracy, but also generates more concise and straightforward answers compared to previous models, particularly in clinical utility scenarios. Overall, O1's improvements in understanding and reasoning capabilities mark a significant step towards developing a reliable AI system for clinical applications.